Alright, Professor Jim Schultz here from my Finance 680 students. I thought I would take a minute and shoot a video going through some basic bond problems that you should all be very comfortable with, kind of heading into, the second section of Chapter 7. I want us all to be pretty comfortable solving these basic problems before we start getting into some more challenging situations that could come as early as Tuesday night, which I guess would be February 20th. So I've got 4 different problems here that I wanted to walk through in terms of how to set up and how to key into your calculators. And so let's go ahead and start with this first problem. The first problem is a really basic bond problem. We have a bond that pays an annual coupon of 6% and matures in 4 years. The yield to maturity on this bond is 4.5%. So what is this bond worth today? Now obviously this is the answer, but let's go through how we got to this answer. First of all, when you see something that says, what is this bond worth today? That is the same as asking, what is the bond's price today? Right? So you want to be comfortable with a few different ways that we could phrase you're trying to find the present value of the bond, right? What is the bond's price today? What is the bond worth today? What is the bond's current value? All these things would lead you to kind of think, I think I'm looking for a present value, right? And that is indeed the case here. Now, the problem doesn't tell us that the future value is 1,000, but until we get into some more complicated situations with call premiums and callable bonds, the future value will almost always be 1,000, so we can go ahead and default to that input. And then it says this bond pays an annual coupon of 6%. Now that makes our work a little easier. We're going to see in some later problems bonds that pay semi-annual coupons. But with the annual coupon being 6%, that goes right in as the payment being $60, which again, of course, that's 6% of the par value, which is 1,000. That gets us 60 for our payment. Now, the yield to maturity on this bond is 4.5%, so your I goes in at 4.5. Remember, the I is the yield to maturity or the required return on the bond or the current market interest rate. It could go by any of those names. Those would all lead you to the same thing, the I in the time value of money equation. And then obviously the N is 4. And so when you key all these inputs in, you're going to get a present value of 1053.81. Now, a quick reminder, with your keys on with your signs on your keys for your calculator, right? For bonds, if you remember in class, I said it's always going to be the same thing. You view the problem from your perspective, which makes your present value negative and your future value and payment both positive. And I would always maintain that convention that will never steer you wrong for basic and even intermediate problems. Even the more challenging problems, I can't really think of a situation where you would need to veer from that methodology to get you to the right answer. So for this particular problem, these would both go in as positive inputs, leading you to have a negative output here. So that's 1053.81. So let's scroll down to our next problem. So this is kind of a step up, going from kind of a level 1 to maybe a level 1.5 or maybe a level 2. This bond carries a yield to maturity of 7% and matures in 5 years. It pays an 8% semi-annual coupon. So looking at this phrase again, if you remember from our discussion last class, that is an annual rate. That denotes how often it's being paid. That does not mean you're getting 8% every 6 months. It almost never means that. Anyone who read that, people in the financial world would read that and understand right away that's an 8% annual number. This is telling me how often the coupon is paid. And again, this problem is asking us for the bond's current price. So that leads us to the present value. Again, the future value is always 1,000 for these basic problems. Now the payment is 40. How did I find that? Well, if it's 8% every year, that's $80 every year. If it's $80 every year, that's $40 every 6 months. So that leads you to a payment of 40. Now the I here is 3.5. Now where did I get that from? Well, the yield to maturity is 7, right? And remember, whenever our payment is on some non-annual frequency, or actually, no, to put it more generally, payment I and N all must have the same frequency. So if this guy's going to be annual, these guys also have to be annual. Well, this guy is semi-annual, so these two must be semi-annual, right? So if that's 7% per year, that denotes to 3.5% every 6 months, or just half of that amount for half of the year, essentially. And then, of course, 5 years, you simply have to ask yourself, how many 6-month periods are in 5 years. And for all these problems, a timeline would certainly help, but just for the sake of efficiency and time, I did not construct timelines for these problems, but timelines would always be useful for you. And so that is how we arrived at an N of 10. A bond that matures in 5 years matures in 10 6-month periods. So that will give you a current price of $1041.58. So moving on. So I wanted to do something a little different in this third problem. Rather than continually solving for the price, let's try to solve for another input. So you see in this problem we end up looking for N, but let's work through the problem. So the information tells me to start, the bond is currently selling for $889.24. So that right away, that's going to be your present value. Right? Oh, performance is not going too well. Let's hope we can power through. So let's X out of that. So this tells me the bond's current price is $889.24. So that goes right into your present value. You know your future value is always 1,000, right? Again, unless you're in a callable situation, that's probably not going to change. The bond pays a 3% annual coupon. So that's 3% a year paid annually, right? So my payment's obviously going to be $30, and my computer is really struggling right now. But let's hope it can make it through. So I'm going to get $30, right, every year. The current market interest rate is 4.2%, so that's going to go right in for my I, for my YTM, right? Because again, I just phrased it differently here so that you can see it in a slightly different way, right? So how long is it going to be until this bond matures? Well, if you simply put in these inputs, and remember, this is negative, positive, positive, it comes right out as 11.92. So that's a fairly simple, straightforward bond problem. So we've got one more. So let's take a look at this. Final one is I set up a situation where I said, all right, we have a bond that matures in 2 years and currently sells for $1047.55. I wouldn't put that information in yet because we have to see how often the coupon is paid. But this right here tells you the bond's price. So that goes in right there. And then obviously, again, my future value always defaults to 1,000. The coupon on this bond is 5%, but it's paid semi-annually. So right away, you say, all right, that's 5%, that's 50 per year, so it's got to be 25 every 6 months. Then what is the required return on this bond? So I kind of, again, threw another phrase out at you guys, but again, I want to get you guys comfortable solving for I when it's cloaked in different terms, different phrases, right? This is just telling you to solve for I. And going back to the first piece of information we were given, if the bond matures in 2 years, that's 4 semi-annual periods, okay? Now, when you do all these inputs and you solve for I, this is the number that comes out, 1.273. But now you have to ask yourself, all right, is that an annual number? And the answer is no, because this was put in semi-annually and this was put in semi-annually. So this is going to come out semi-annually, right? And again, remember, we always want to present our answers annually. So if this came out semi-annually, I've got to multiply that guy by 2 to get my annual required return on this bond. So hopefully this video was helpful for you all in terms of working through some basic bond problems, and I'll certainly put together another video kind of moving into some more intermediate and more challenging problems.